All right, so we've been talking all about reactions in aqueous solutions. Now it's time to talk about how we express concentration. How do we talk about concentration of chemicals in solutions? And the answer is molarity. Molarity is capital M, like this, abbreviated with a capital M, and it means the moles of solute per liter of solution. Now, do you remember what solute means?
That's the stuff that's being dissolved in the solvent.
That's right. And the combination of the solute and the solvent make the what?
I don't know.
That's the solution, right? A solution is the solute and the solvent.
Yeah, I knew that.
Okay, so when we say 6 molar solution of HCl, for example, that means it contains 6 moles of HCl in every liter of the solution that we have. So just to reemphasize, when I say big M, that means moles of solute, liters of solution. And this here turns out to be a very powerful conversion factor, right? We can use how many moles there are per liter of solution to identify how much material we have to use to make a solution. We can use the molarity here to determine what the concentration of a given reactant is, if it's going to react with our stuff here. This also, liters of solution for every mole of solute, is a very helpful conversion factor as well. It's the same thing, just flipped. Molarity is specifically that. So if we're solving for molarity, these are the units that we're after. But if we know the molarity, we'll have access to this conversion factor as well. Okay, very good. So let's do some practice problems using molarity as a conversion factor. What's the molarity of a solution created by dissolving 10.2 grams of KNO3 in enough water to make 350 milliliters of solution? All right, so what is it we're after to the right of our equal sign?
Oh, molarity?
Very good. We're after molarity. Now, what were our units for molarity?
Moles per liter.
Very good. So moles of what in this case?
Moles of KNO3.
Good. Moles of KNO3 for every liter of solution, right? Liter of solution. That's what molarity means. Okay, now I can draw my line like so, and I can start with my KNO3, the amount that I have on top. 0.2 grams of KNO3. Now I started with that on top because I want my moles of KNO3, and it should be pretty easy for us now to go from KNO3 grams and convert that to moles. How do we do that?
You just need the molar mass. It's provided, 101 down there.
Good. So 101 grams for every mole. Now I'm in moles of KNO3. Now I just need to get my liters of solution on the bottom. Do I know how many liters?
Well, it says 350 milliliters of solution.
Very good. So it does say 350 milliliters of solution. So I can write in there 350 milliliters, and then I can just convert my milliliters to liters. 1,000 milliliters for every liter. All right. So my milliliters cancel out. I'm left in liters of solution. My grams of KNO3 cancel out. I'm left in moles of KNO3, and that's what I wanted. The moles per liter, or the molarity of my solution. Okay, very good. So 0.29 molar should be what you get when you put that in the calculator. All right, okay, try this one at home, the next one here. See, it's new, but using our same method, right? Conversion factors of molarity, right? Try to find out what mass of KNO3 is found in 25.33 milliliters of my 0.05 molar solution. Okay, give it a shot. Okay, after you've tried it, want to help us out, Fred?
I can't do much here, I really don't know, but I know what goes to the right of the equal sign.
That's exactly what we want. That's all we want, actually. What goes to the right of the equal sign?
Grams of KNO3.
Very good. Grams of KNO3. Okay, Now, what is going to go to the top left here?
Do you want to start with the milliliters or the molarity?
Well, we know that we can get moles of KNO3 to grams of KNO3, don't we?
Yeah.
So can I write 0.05 moles of KNO3 for every 1 liter of solution? See that?
Oh, that's the molarity.
That's right, moles of solute per liter of solution. Okay? Looks like we're missing an L in there. All right. So if I have moles of KNO3 per liters of solution, I can go from moles of KNO3 to grams of KNO3, right?
Yeah, that's 101 again.
Very good. And now I can take my liters of solution. What do I need with liters of solution?
Well, you don't want them this time.
That's right, we got to get rid of them. So how can I get rid of them?
I don't know.
Well, see, it says that I used 25.33 milliliters of this solution, or we're wondering how much mass of this material is found in that volume of this solution. So I have that liters of solution in milliliters, 25.33 milliliters of solution, and then I can convert my milliliters of solution to liters of solution, 1,000 milliliters for every liter. Okay, you see that?
Don't you need something underneath the 25.33?
Down here? We don't. All we're trying to do is get the units to look like they're supposed to look over here at the end. So we got moles to grams, that was good. And then we got our liters here, and we converted our liters to our milliliters. All right? I guess it would have been better intuitively to go liters to milliliters first and then put the milliliters over there. But both ways work. Okay, very good. So here's another good practice for you. Why don't you try this one at home, and then we'll try it together. All right, make sure you tried it at home. What goes to the right of the equal sign?
Molarity.
Okay, now is it good for me to just write then? Just write equal sign big M, molarity.
Well, I don't know, is that bad?
Well, what would be the problem with that?
I think it's okay.
It is okay. It's not a terrible problem. But if I write it instead as equal sign moles of, in this case, NaCl per liter of solution, right? Can you see how that is, in a way, giving me a little more detail than just molarity, right? It's separating up into moles of our solute and liters of our solution. And that's what we want, because this is our roadmap, and so we want to be very clear about where we're trying to get. Okay, so now we can start with what on top?
10 grams of sodium chloride. You want to convert that to moles.
Very good. 10 grams of sodium chloride. We're going to go grams of sodium chloride to moles of sodium chloride. Okay, and then I got moles of sodium chloride on top. That was easy.
That's 58.
What's that?
58.43.
What are you talking about?
That's the grams per mole of sodium chloride.
Oh, okay, right. 58.4 for every mole. Okay, and now what do I need to do?
Now you just need the liters of solution, which is 75 milliliters. That's 0.075 liters.
Okay, so are you okay if I go 0.075 liters? I converted that milliliters of solution in my head. Is that okay?
Yeah, that's okay.
Okay, so now I am in moles of sodium chloride per liters of solution, right? So that's how I get the answer. 10 divided by 0.075, 2.28 molar. Okay, good job. Excellent. We'll see you next time.
Oh, okay, bye.